everyone, welcome to CodeSoft. In this video, we are going to discuss a problem that is leaders in an array. So let's get started. Now, what does the problem statement tell us? It says that write a program to print all the leaders in an array. An element is a leader if it is greater than all the other elements that are present on the right side of it. And the rightmost element is always a leader. Now, why the rightmost element is always a leader? This is because there are no elements present to the right of it. That is why it is greater than all the elements to the right of it. And so it is a leader. So let's see an example test case of this problem. Suppose we are having an array that is 16, 17, 4, 3, 5, and 2. These six elements are present in the array. Now if we talk about 16, so 16 has 5 elements to the right side of it, that is 17, 4, 3, 5, and 2. Right, but you can see that an element 17 is greater than 16 and is also present on the right side of it. That is why 16 cannot be a leader of the array. Similarly, if we talk about 17, so 17 has 4 elements on the right side, all of them are smaller than 17, so 17 is a leader of the array. If we talk about 4 and 3, so there is an element 5 present to the right side of both of them. So 4 and 3 cannot be a leader of the array. And now 5 is having only one element to the right side, that is 2, which is smaller than it. So 5 is a leader. And 2 is the rightmost element, so that is also a leader. So there are three leaders in the above array, that is 17, 5, and 2. Now I would request you to pause the video and try to solve this question on your own. If you're not able to solve it, then I would recommend you to please watch this video. Now let's see what is the brute force approach for this problem. The brute force approach is very simple. What we have to do is we need to go to each element, check whether all the other elements on the right side are smaller than it or not. If they are smaller than it, then our particular element is a leader. Otherwise, it is not a leader of the array. So if I talk about the brute force approach, so if in steps, so step one is go to each element of the array. Step two is compare it with all the other elements of the array. If it is greater than all the other elements, then it is the leader, otherwise not a leader. So this is the code for this brute force problem. What it says is that first line is we have declared an array. We have written int n equals to 6 because there are 6 elements. Now what we have to do is we have to go to each element one by one. So this is done using a loop that is starting from 0 till n. Now suppose we have picked one element, then we have declared a variable that is int flag equals to 1. Now this flag means that if flag is 1, then our particular element is a leader. If flag is 0, then it is not a leader. How this is useful, let's see. Now we have picked an element. What we will do is we will start another loop that will start from I plus 1. That is, it will traverse to the right side of that particular element and it will go till the last element. It will check if any element to the right side is greater than it, that is, if ARRI is less than ARRJ, then we will just put the flag equals to 0. That means there is a presence of a greater element on the right side, and so our particular element cannot be a leader. At the end of this inner loop, we will just check if the flag equals to 1, that is the element is a leader or not. So if flag is 1, then it is a leader. We will just print that particular element. And you can see the output we are getting, that is 17, 5, and 2. This is the required output. So our code is working fine. Now this brute force approach is actually taking around O of n squared time because there is a nested loop present in it. We can actually optimize this solution, and this is the optimized logic. So we will code this optimized logic. Let's go one by one. So the first step is mark the first rightmost element as leader always. Okay. So what we can do is first let's try. So the leaders are, now what we have to do is we have to mark the first rightmost element as a leader. This is because there are no elements present on the right, so this will always be a leader. Now the next step is create a variable as right max and save the rightmost value in it. So till now we have only seen one element, that is the rightmost element. So let's put the right max value as the ARR n minus 1. What this means is that suppose we are just at this point when we are traversing from reverse, we are at this point, there is only element present 2, and so it is the maximum value till 2. Okay, now what we have to do is we have to traverse from n minus 2, that is from the second element, second last element, and we need to go till the start. So basically we are traversing in the opposite manner. What we are doing is, let's just talk the algorithm for once. What we will do is we will mark 2 as the right max. Okay, then we will go to 5. It will check that whether 5 is greater than right max or not. If 5 is greater than right max, then it is a leader. Okay, if it is the leader, then we will update the right max as 5 because this will now become the rightmost maximum value. After that, we will go to 3. We will compare it with the rightmost maximum value, that is 5. 5 is greater than 3, so 3 cannot be a leader of the array, and we will move to the next element, that is 4. So similarly, when we will reach 17, 17 is greater than 5, that is the previous right max. So 17 will become the leader, and also we will save the value 17 in right max. So this is the algorithm. So we are starting from n minus 2 till the first element. What we will do is we will compare this value with we will compare this value with right max. If this is greater than right max, we will just print this value because this becomes another leader. Cout arri. And what we will do after this, we will update right max as arri because this is the new right max value. And that is it. By the end of the loop, we will get all the right max printed. So if I just run this value, okay, this is saying an error, that is okay, so what we have to do is we have to place a equal to sign over here, and now running. So we are getting the leaders as 2, 5 and 17. This is the required answer. So this is the optimized logic to this problem. I hope this is clear. This will just take the time complexity of O of n and is a very efficient solution. So that's it. Thanks for watching. Stay tuned to add more festoons into your knowledge garland. Until then, please keep subscribing. Thank you.